Today is Wednesday, October 17th, and we are doing Module 2, Lesson 8. Today, we are just going to use the standard algorithm to help us multiply numbers. We've had a lot of practice with area models, and we've seen how area models relate to the standard algorithm. So today, we're directly going to just use the standard algorithm. Remember, the standard algorithm, there's several things you need to keep in mind to be precise. You need to know your math facts. You also need to make sure you line up all your place values, okay? But the one thing we are going to be doing today before we use any standard algorithm is we are going to be using estimation to help us see if our answer in the end is reasonable. Today you will always have to write out your estimation, and I will show you what that looks like in a little bit. The directions tell us today to estimate the product first. And then we're going to solve by using the standard algorithm. Then we're going to use our estimate to check how reasonable our product is. Okay, so we're going to think to ourselves that the problem is 314 times 236. We're going to first estimate. We're going to think about how big should my product be. I can show that I'm estimating by using my wavy equal signs. 314 is pretty close to what number, everyone? 300. Okay. 236 is pretty close to what number, everyone? 200. Oops, 200. Thank you. Okay, and then I can use a regular equal sign because I'm actually going to solve 300 times 200. What's 3 times 2? 6. And then how many factors of 10 do I have? So I have to add 4 factors of 10 to my answer. So I know that my product should be pretty close to 60,000. Now, let's actually do the standard algorithm. Let's set that up over here. And we can use our estimate at the end to help us decide if it's reasonable or not. Okay, first we have to do 314 times 6, right? But we're going to start in the ones place of 6 times 4 and then move our way through each digit. So what's 6 times 4, everyone?
24.
24, very nice. Sorry, move this down a little bit. Okay, 24. I'm going to write the 4 down, but I'm going to regroup those two 21s as 2 10s. Okay. What's 6 times 1? 6. So we have 6 10s, but I have 2 more 10s here. So how many 10s do I have altogether?
8.
What's 6 times 3?
18.
Okay. Write that down. So what's 314 times 6?
1,384.
If I did an area model, that would be my partial product of that column, right? Now let's move on. We're going to do 314 this time times what? Times 3, but the 3 is in the tens column, so it's really 314 times 30. And because I'm automatically doing times 30, if I want to think about it as 3, I'm going to ignore that 0 for now, but how many factors of 10 would I need to add on later? So let's add that factor of 10, and that's our placeholder 0. Does that make sense, why we put that 0 there? Okay, what's 3 times 4? Okay, so I'm going to write 2 of those, but I'm going to regroup it as 1. Let me erase that. And regroup it as 1. Very nice. Okay, what's 3 times 1?
3.
Plus 1?
4.
Okay, what's 3 times 3?
9.
So what's 314? Listen carefully. What's 314 times 3?
942.
942, right? What's 314 times 30?
9,000.
Okay, you guys see what we're doing, right? Okay, now let's do 314 times 2, but it's really times 2 what?
100.
So how many factors of 10 are there?
2.
Let's add those 2 factors of 10 first. What's 2 times 4?
8.
2 times 1?
2.
2 times 3? 6. Okay, listen carefully to my question. What's 314 times 2?
628.
628, right? But what's 314 times 200?
62,000.
Now, to find the total product, I have to add my 3 partial products. 1,884 plus 9,420 plus 62,800. When I do that, how many 1s do I have altogether?
4.
How many 10s do I have altogether? 10. So I'm going to record 0 of them because I'm going to regroup all of them to become 100. How many hundreds do I have altogether? 21. Very good. I'll write 1 of them and regroup 2 of them as thousands. How many thousands do I have altogether? 14. So I'll write 4 of them, regroup 1 of them as a 10,000. How many 10,000s do I have altogether?
7.
So what's my total product? 74,104. Is that pretty close to my estimate? Does it at least have the right number of place values?
Yes.
So that tells me, yes, my answer is in the right zone. I checked back, and this check helps me see that you thought back to the estimate. Does that make sense? Okay, so that check just says, yes, I checked it. Now, could you estimate and put a check first? You could, but doesn't that defeat the whole purpose of why you estimate first? Okay, so at the end, once you have your total product, come back, show me that you're looking at your estimate, and put a check there if you think it's in the right zone. This time, we can estimate that the product should be pretty close to 2,000 times 300, right? So what's 2 times 3?
6.
And then how many factors of 10 do I have?
5.
Okay. Let me ask you a question. Do you think the actual product will be bigger or smaller, greater or less than 600,000?
Less than.
Here, you'll notice that I made 18,882 bigger to get to 2,000. Yes? Same thing with this one. I made it bigger to get to that. So this estimate is going to be bigger than my actual answer will be. Right? So my actual answer is something bigger than 600,000. Can I feel confident that something is right? Can I?
Yes.
If my actual answer is larger than this, I'll feel sad because probably I'm wrong. So I'll go back and check my work. So now let's do the standard algorithm and see if we truly get something smaller than 600,000. Now that we know that our actual product is 557,072, how does that compare to our estimate of 600,000? Does it have the same number of place value units? Okay, that's good. It shows we're kind of in the right zone. Is it greater or less than our estimate? Did we want it to be less than our estimate? So we feel good, and we can put that check mark saying, my estimate says that my answer could be correct. If a problem says, without calculating, should I see work that you did 1,729 times 308 in the standard algorithm like that? No, because that is literally calculating, and it says without calculating. Okay, so what could we do? Again, he did 1,729 times 308, and he got his answer of 53,253. How can we see if his answer is reasonable without doing the standard algorithm and seeing if we get the same answer? What could we do? Akil? We could estimate. Okay, so 1,729 is pretty close to what number? 2,000, okay. And 308 is pretty close to what number? 300. So what's 2 times 3?
6.
How many factors of 10 do we have?
5.
So does it seem like his answer is reasonable?
No.
It's way too what?
Small.
Way too small. So the answer is no, because you can see this only goes to the 10,000s, whereas our estimate shows that we need to go to the 100,000s. So the answer is no. His answer is not reasonable.